Hello everyone, my name is Finding Pepper, and welcome to the Tile Scrolling Platformer expansion, where we are expanding on a tutorial series made by Griffpatch, link to which is in the description. This episode is very exciting because we are adding solid entities. What is a solid entity, you may ask? Well, it's an entity that's solid. We have our tiles, right? We have collision with our tiles. We even have slopes, but they're all just tiles. What we're adding today is collision with things other than tiles, aka entities. What this means is that we can add things like moving platforms. We'll do the moving part next episode. This episode will just focus on creating a static solid entity which you can collide with. So how do we want to do collision? Well, one option is to use the touching block. You could create a new sprite called solid entity, and somewhere in the Mario sprite, test if touching solid entity, and then have some collision scripts. But there are some issues with this. Issue 1 is that we need to create a whole new sprite. It's not actually that big of a deal, but it's nicer to be able to use the existing enemy sprite. Reason 2 is that this is a scrolling game, and the touching block goes based off of our X position variable, but we want to test collisions based on our custom-made X variable. Problem 3 is that this does not work off-screen. So if we're, say, falling really quickly so that we're off-screen, not that that will happen, but there's a chance, then we would go straight through the platform. Problem 4 is that it is quite difficult to tell where the edge of the thing that we're colliding with is. As in, it is very difficult to know where we should push Mario out to. So, we're going with a different option. Maybe more complicated, but also in the long run probably simpler. We're going to create a list that holds the positions of all the entities. Not only their positions, but also their width and height, and solidity, and also their speed. Then we'll be able to do some rectangle to rectangle collision scripts between our player and our solid entities. The downside is that all our entities have to be rectangles. However, I don't think this will be too much of a problem. Even if you have some oddly shaped entity, it's probably not going to be too big of a deal. Anyway, our collisions with the tiles are also handled completely as rectangles because we have width and height variables. Alright, so let us actually start doing things. Create a list for all sprites called entity positions. For all sprites. Let's find the one I start as a clone block. I'm going to create a custom block called when I start as a clone, run without screen refresh, and put everything in here. Then I'm going to add some things to it. So each entity will have 7 bits of data. Solidity, X, Y, width, height, speed X, and speed Y. So I'm actually going to create a new variable, data amount per entity for all sprites. And I'll just manually set that here to 7. Cool. That way it's easy to add new bits of data to entities if we feel the need to. Anyway, let us add 7 things to our entity position list. We'll make a new variable, solidity, for this sprite only. This will hold whether it's solid or not. Or possibly we could have jump through solid entities. Maybe. It's a possibility. We'll add X, and then Y, and then width and height, and then our speed X and speed Y. These are all our data. We'll also, before we do this, set and then create a new variable, entity ID, and this will hold what position in the entity positions list its data is stored at. So we'll set entity ID to the length of entity positions plus 1. So this is setting it before we add all our data, so this will in effect set it to the index of the first piece of data. Now we'll go into the set type custom block and we'll edit it. We'll add an input for solidity. So add a text label solidity and an input solidity. Okay. Set solidity to solidity. Now, in the move enemy, we need to go to the bottom, and I'm going to remove all of the stop this scripts blocks here, because we want this to happen for all of the different types, and we want it to happen after they've moved. So we're going to update their data in the entity positions list, and we will use entity ID. So replace item entity ID of entity positions with, then the first is the solidity, then the next we'll do entity ID plus 1, we'll replace it with X, and then plus 2 we'll replace with Y, plus 3 with width, and plus 4 with height, plus 5, and plus 6 will be speed X and speed Y. So, if we run this, we should see our entity positions list has a bunch of entries in it. Let's look at this one here, because this is an entity that is on screen and is moving. And you can see its numbers updating. That's great. Let's try to smush the entities. Now, what we'd like to happen is for their items in the entity position list to be gotten rid of, but right now they just stay there. So we need to use the delete clone custom block. If you've watched to episode 19, I believe, you'll already have this block, but I'm doing mine with episode 18 scripts, so I'm going to create a custom block, delete clone. If you already have it, just find it. Now, if you don't already have it, and maybe if you do, I can't remember exactly, but either way, you'll need to check very carefully that every instance of a delete this clone block will be replaced with our custom block. And I'm also just going to stick delete this clone on here. So I'm going to start in the top left, and then move down the columns of code blocks, checking for if I see any delete clone. And I'm going to go to the next column and then do that again. I'm going to do this with all my code, and I'll let you know if I see any delete clone blocks. Here's one. Move enemy near the top, and another one just below it, if type equals squish. There's one in when I receive entity clear. I will replace that with a deleted clone. And also in take life, when we are touching Mario, I will delete clone. And I believe that is it. So let's make this block a little bit bigger than just delete this clone. We'll first check if type is greater than blank. That means it is actually a clone, because if type is blank, then it is the main entity sprite, not a clone. Then we'll repeat data per entity, and we'll delete entity ID of entity positions. So this will delete all of its data. However, if you think about it, all entities with a higher entity ID than this will get their data shifted. So we need to tell them that this has happened, that the entity positions list has shortened, and that it needs to modify its entity ID to match the new position in the list of its data. So we will broadcast a message called entity deleted we'll create a new one and create a variable called deleted entity ID for all sprites. Set deleted entity ID to entity ID, and then have a when I receive entity deleted. If the entity ID is greater than the one that was deleted, then we'll change entity ID by 0 minus data amount per entity. So we need to shift it upwards in the list to account for the fact that there are now less items in the list. Now, one last thing we need to do is when flag clicked, the flag automatically deletes all of the clones, so we will delete all of entity positions. So, notice we have 84 items in our entity positions list. When we stomp on a Goomba, it should decrease by 1. Down to 77, and then down to 70. Let's just try dying. Make sure that that works correctly. And then it gets restored to 84. And yes, it does. Wonderful. Great, this is all working as expected. Next, we'll create our entity that will be solid. So, I'm going to paint a new sprite, bitmap mode. It will just be a rectangle. You can make your rectangle whatever size you want, but make sure you know what size it is. Each of these little squares in the costume editor are 4 pixels. So mine is going to be 32 by 16. You can see its size down here under the costume name. I'm going to call it box, and I'll drag it into the tile sprite. Let's look at the costume 70. The editor, I'll add it to the tile keymap list. Add a 9. And yeah, this is all just standard, adding a new entity stuff. The spawn type block in the enemy sprite, if tile type is 70, we'll set type box. The costume will be 34. Yours will probably be different. And the width, 32, and height 16. Remember that width and height are actually 1/2 of the total width and height. However, our enemies are of size 200, so this is actually correct. We'll make the solidity hash. I'll use the same notation for the solidity of entities as for the solidity of tiles. The Mario sprite. Let's actually begin coding our collision scripts. Find some free space. I'll create a new block called fix entity collision in direction dx, and then an input dx, dy, then an input dy. Run without screen refresh. So the dx and dy inputs are the direction in which the player is moving, or rather the speed of the player. So we're going to loop through the entity positions list. So we need a variable to hold our current position in it. So I'll make a variable called e-hash. That stands for entity number. If you can't remember what that stands for, I'd suggest writing it out, entity hash or entity number. This will just help you remember exactly what that variable is used for. But I'll just keep it as e-hash. So I'll start by setting e-hash to 1. Then I'm looping through the list, so I'm going to repeat length of entity positions, and then we need to divide it by the data amount per entity. Because if our list is 70 items long, and each entity has 7 bits of data, then there's actually only 10 entities. Now each time I will change e-hash by data amount per entity. We only care about this if the entity is solid. So, if item e-number of entity positions equals hash, then it is solid. Remember, the first bit of data for an entity is its solidity. Let's talk about how we know if we've collided. 4 things need to be true. Number 1, The right side of object 1 needs to be to the right of the left side of object 2. Number 2. The left side of object 1 needs to be to the left of the right side of object 2. Number 3. The top side of object 1 needs to be above the bottom side of object 2. Number 4. The bottom side of object 1 needs to be below the top side of object 2. Now, I know that is a little bit confusing, so that's why there is this picture. Hopefully that will help you visualize it a little bit. Now, let's convert these 4 things into something closer to code. We know the player and entity both have an x, a y, a width, and a height. And we can use that to find the edges. So for number 1, if x1 plus width 1 is greater than x2 minus width 2, because remember, we add to get to the right edge, and we subtract to get to the left edge. Then for number 2, if x1 minus width 1 is less than x2 plus width 2. For number 3, if y1 plus height 1 is greater than y2 minus height 2. And for number 4, if y1 minus height 1 is less than y2 plus height 2. I would recommend that you pause the video here if you don't fully understand it, and try to understand exactly what I'm saying and why this is true. Now that we have these 4 conditions, let us actually code something. The object 1 in this position will be Mario, and the object 2 will be the entity. So we'll make variables ex, ey, all for the sprite only, by the way, ewidth for the sprite only, and eheight for the sprite only. Okay, now let's just start by setting these things to what they should be. So ex will be item enumber plus 1 of entity positions, that is the x. Ey will be enumber plus 2. Ewidth will be enumber plus 3, and eheight will be enumber plus 4. Now we'll have a series of if statements to test our 4 conditions. For the first one, we have x plus width is greater than ex minus ewidth. Number 2, if x minus width, that's the left edge, is less than ex plus ewidth, which is the right edge of the entity. Now, for the y, we'll replace the x's with y's, duplicate the outer if statement, y, and the width for height, ey and eheight. Okay, so it should look like this so far. And then we'll finally do the same for the bottom edge being below the top edge. So these are our 4 conditions. Make sure you take note of what direction the greater than and less thans are pointing in, and the pluses and minuses. Those are very important. Now, if we've collided, we'll use our solid variable. I'm just going to set solid to the empty value up at the top, and then if we have collided with something, then we'll set it to 10. I don't know why Griffpatch chose to use 10, but, you know, that works. We could maybe set it to a different number, like 9, if we want to be able to test whether we're colliding with a moving platform or a tile somewhere else. But I'm just going to leave it as 10. So, I'm going to just show the solid variable. And I'm going to run this and get rid of these Goombas. And then I'll go over to our solid entity. And see, when I jump, the solid becomes blank up in the top left. However, if I jump into the solid entity, it should stay 10. Okay, sorry, that is my mistake. That is not actually going to be true because we haven't used this block anywhere. However, I am still going to jump into it and I have Scratch add-ons, so I can pause the game at any point. And now I'm going to use my block, and you'll see Mario Solid is indeed 10. So we are recognizing that we're colliding with these entities. If you don't have Scratch add-ons without a pause button, you can either just time it well, but that's kind of hard to see, so you can also just trust that it's working like my code says it is. Depending on what direction we're moving, we're going to be pushed out in a different direction. Let's start by if we're moving right. Let's start for if we're moving down. So if dy is less than 0. This means we have a negative speed y. We're moving down, so we want to be pushed up. Now, where should we be pushed up to? Well, we should be pushed up so that we are standing flush with the top of the solid entity. So I'm going to set y to the y position of the entity. So that's EY. And then we need to add the entity's height and our height to it, so that the bottom of the player will be at the top of the entity. Okay, we'll do the same for if we're moving left, but replace all the y's with x's. So dx is less than 0, set x to ex, and then we need to replace the heights with width. So e width plus width. Now, let's do it for if dy is greater than 0. That means we're moving up. So we need to set y so that our head is at the bottom of the entity. So this time, we'll subtract our height added together from the entity's y position. And then, same for moving to the right, we need to be pushed out to the left. So, ex minus e width plus width. Okay, now, going to do the same thing I did before. I'm going to grab a block, and I'm going to use my Scratch add-ons pause button. By the way, if you don't have Scratch add-ons, you really should get it. Okay, so I'm colliding with the entity. Now, let's fix collision in direction 0, -1. So that means I'm saying I am going down, so I want to be pushed back up. Run it. And look, we briefly saw our player jump back up to the top of the platform. Now, theoretically, if we're running this every frame, we should stay on the top of the platform. So let's do that. Go to the move sprite y, make some space, and then we'll use our fixed entity collision interaction, dx0 and speed x speed y, dy speed y, and then we're going to copy the thing above here. Great. So we want the same thing to happen if we collide with an entity that we do if we collide with a tile. We're going to go to move sprite x, make space. Now, a lot of this is dealing with slopes, so we're going to have something a bit simpler than what's above there. We're just going to fix entity collision interaction dx speed x dy 0. And I should point out that we're putting 0 for the speed y here, just so we only fix collisions in one direction. And so, say if we're moving to the right into an entity, that we don't get pushed up, we get pushed back to the left, if we're moving in the move sprite x portion. That's why we separate the x movement and the y movement. Okay, here we'll just duplicate this little bit in here. If solid is greater than 0, we'll set speed x to 0. Run this. Let's try walking on top of the solid entity. And look, we can stand on it. This is incredible. I'm going to place one on the ground so I can easily test how sideways collisions work. There we go. We are colliding with this side, and let's see if maybe I can fit in this little gap. And yes, I can. And we cannot move anywhere. Alright. Let's test collision for the bottom then. I'll put one a bit higher up. Let's jump into it, and wait, hold on. What's that? We're not making it all the way to the block. We are colliding with it before we even reach it. What's going on? Well, we are Mini Mario, but our height is as if we are Big Mario. Let's go back into Fix Entity Collision Interaction. And this test right here, this is what we need to change. We're checking if our y plus height is greater than the entity's y minus the entity's height. So that means if the top of our head is above the bottom of the solid entity. Now for Mini Mario, the top of our head is not in our y position plus our height, it's just at our y position, because our head is actually in the middle of our sprite. So we're going to get an OR. If not Mario equals Mini. So if we are not Mini Mario, then we can do the normal collision check. If we are Mini Mario, or Mario equals Mini, and we'll just check if y by itself is greater than the bottom of the entity. Let's run this, and now we jump into it. Aha! We are colliding with it, however we are getting pushed out back as if we were still Big Mario. So let's fix that. It is this dy is greater than 0, so we're moving up. If else, if Mario equals Mini, and we'll put this in the else, this will be our normal collision. If Mario is Mini, we'll set y to simply the enemy y minus the enemy height. Because remember, we don't need to subtract our height from that. Alright, jump into it again. This should feel great. Awesome. Let's collect a super mushroom. And now we should no longer be able to walk under this small one, and our head should collide with this one right here. Okay, yeah, this is great. We have solid entities. Let's get some interesting shapes going on here. See, we just tested collision with, corners worked fine. And that looks great. Okay. Wonderful. Let's see what happens if we try to place down a Goomba. Grab a Goomba, place it down, see what happens. And, yup. You probably expected it. The Goomba is going to walk straight through the platform. Obviously, right? Because we haven't coded collisions between enemies and solid entities. We can actually just use our fixed entity collision indirection block. Just drag it into the enemy sprite. And I'll put it off to the side somewhere. Now, we of course need to use this block in our move sprite X and move sprite Y, just like we did before. Fix entity collision indirection dx speed x, remember this is move sprite X, dy is 0. And then we'll copy this. If solid equals 0, then we'll set speed x to 0 and turn around. Now, let's do for y, make space, and fix entity collision in direction dx 0, speed y, speed y. Actually, we can even remove this jumping, because enemies don't jump. So I'll put this back here. Blocks. Yep, we can delete the jumping variable. Then it should collide and turn right back around. Lovely. Okay. Let's see, just make sure it works if the Goomba is standing on top of the platform. Yep. All good, all good. So, we now have solid entities. The next step is to make solid entities which move. That is a little bit tricky, as we shall see next episode. But until then, I hope you have a great rest of your day. Hope you enjoyed the video, and goodbye.